In question number 2, we're going to solve each polynomial equation by factoring. These are the polynomials that were quadratic-ish or quadratic-like. Remember, the key on this is make sure that your powers are halvesies of each other. So as long as this power of 2 is half of 4, we've got a possibility of converting this into a quadratic type equation. So we made these adaptations to it. We said make the substitution where u is equal to x squared. So we're going to replace this x squared with u. Then u squared would have to equal x to the 4th. So those are the substitutions that we made to make it more quadratic-like. So the x to the 4th is going to be replaced with u squared. That's just a direct replacement substitution, plus 12 times, and instead of the x squared, we're going to put in a u, minus 8. And we want to be able to solve this by factoring. So this should have been set equal to 0. So now we're going to solve this quadratic style equation either by factoring or completing the square. So trinomials, if factorable, will factor into two binomials. So I can come over here and I can say, what are the factors of 8? Well, I can do 1 times 8, I can do 2 times 4. The sign is negative, so that means can I subtract these two in any order to get a 12? And with a quick glance at those factors, that's not going to work. So now we've got to go back to another strategy that never fails us, and that is a quadratic formula. So really what we're going to have to do is take this equation and solve it using the quadratic formula. So in order to find the values for this equation, our values for u are going to be equal to the opposite of b, which is negative 12, plus or minus the square root of, well, the b squared, which is 144, then minus 4ac, so it's going to be minus 4 times negative 8 times 1, so negative and negative is positive, and 4 times 8, that is 32, all over 2 times a, which is 2 times 1. So I plugged and chugged a little bit into our quadratic formula. So we're going to do some rounds of simplification now. It's negative 12 plus or minus the square root of. That'll be 176 all over 2. At this point, what I want to do is I want to simplify that radical. So what we want to do is see, are there any perfect squares that go into 176? So I'm going to do a combination of two things. I'm going to start splitting up this monomial division. It's a negative 12 divided by 2 plus or minus the square root of 176 all over 2. Well, I want to start testing 176 and seeing what kind of perfect squares will go in there. Well, one of the perfect squares that goes in there is 4, but there's a bigger one, which is 16. 16 divides into 176, so I'm going to rewrite 176. That square root of 176 is going to be converted into 176 can be written as 16 times 11. So if you take 16 times 11, you're going to get 176. But I can take the square root of 16, and the square root of 16 is 4. So this becomes 4 times the square root of 11, and that is simplifying that radical square root of 176. So it's 4 times the square root of 11 all over 2. Then I'm going to simplify each of these fractions. So negative 12 divided by 2 is a negative 6, plus or minus. The 4 and the 2 have a common factor, so this 4 and this 2 have a common factor of 2, so it's 2 times the square root of 11. Now that is what u is. So we just found the solutions that satisfy what u is, but we got to go back and remember what u represented. So I'm just going to stroll back up here and remember that u represented an x squared. So we have to replace u with x squared to get our final solution. So take out the u, put in an x squared. So x squared has to equal this negative 6 plus or minus 2 times the square root of 11. To get rid of squaring, we square root. So x is plus or minus the square root of a negative 6 plus or minus 2 times the square root of 11. Now this is quite a bit messier than we normally have had. I didn't intend for it to be this messy, but it did just get there, so we just will deal with this. So it says we have 2 answers sitting here. Remember, this is a 4th degree polynomial, which means it has to have 4 answers. There's a plus minus there, so there's 2 answers sitting out there, and there's a plus minus sitting in here, so that means we have 2 answers that can go along with each of those plus and minuses. So here's what we really are looking at. We've got one set of solutions that is plus the square root of negative 6 plus 2 times the square root of 11. So we have that plus and minus for that one. And then we also have, in another round, a plus and minus square root of a negative 6 minus 2 times the square root of 11. So for each of these plus and minuses I have here, I have a plus and minus on the outside. Well, 2 times the square root of 11, I just wanted to illustrate to you kind of what the value of that number is. So if I take 2 times the square root of 11, that is 6.6. So when we do this addition in here, it's really like taking a negative 6 plus 6.6-ish. The point I want to illustrate on this one, I'm going to get a positive number underneath there, so it's really going to be taking plus or minus the square root of a positive value. That's going to be just fine. Those are our real answers. They are not our complex variety. So that's just going to be our solution set there without any more simplification. Our answers are, in this one, I'll try to get rid of that stuff down here. I just wanted to illustrate that these answers will be positive and they will be real. So these answers will be plus or minus the square root of negative 6 plus and minus, plus, 2 times square root of 11. On the other hand, these down here, if I look at these, it's going to be negative 6 minus 6.6. And when we do these calculations, we're taking the square root of a negative. So these square roots are going to be representing imaginary or complex numbers. So on this one, I might make one small adjustment to your final answer, be plus or minus the square root of a negative 6 minus 2 times the square root of 11, and just put the I out there. It's probably not the most ideal format for these, but for our purposes right now, that will satisfy the conditions of this problem. So there are really 4 solutions here, 2 of them that are real answers, and 2 of them that are complex, true, pure imaginary complex numbers. So there's a total of 4 answers there.